Okay guys, so in this next problem, we're still talking about the principle of work and energy. So in this one, notice we have a motor that's exerting a force of 600 plus 2s squared newtons on the cable. And they're asking us to determine the speed of the 100 kilogram crate once it rises 15 meters. The crate is initially at rest on the ground. And this one, notice we have a variable force. So let's write everything that we have so that we can solve this problem. So as I said, the force is 600 plus 2s squared newtons. So notice it's a force that's a variable of position. So that should come in a little later. We know the mass of the crate is 100 kilograms. We are moving this 15 meters starting from the ground, and we know that the velocity at the beginning is 0 meters per second because it starts from rest. And we are looking for the speed 2. So find V2. What is that final speed once it reaches the 15 meters right there? So let's draw the free body diagram of the box or of the crate. So we have here the crate, right? And as it's on the air, its weight is acting downwards, and on top we have the force acting from the motor. But notice over here that the force of the motor, it's this one. This is force M, that's given, right? Which is that equation right there. But then it divides into two cables attached to that pulley. So the force over here that the crate experiences is this one and this one. So it's twice. So the force over here should be twice the force of the motor. So that's why the pulley comes in handy, so that it does some of that leverage. So using these values, then we can solve this. So once again, from principle of work and energy, we will have T1 is equals to the sum of work from 1 to 2 is equals to T2. Because this one starts from rest, we can get rid of that one. We have then the force, the work, so that will be negative 100 kilograms times 9.81 meters per second square times the 15 meters that it rises, right? Plus the force of the motor, so this will be twice the force of the motor ds, right? Move some up. So this one, notice once again, the force is variable, so it's not just a matter of plugging it in. This is so we have to figure out how to solve for a variable force, which we did show you at the beginning. Remember, go back to the first video so you guys can see how we work with that regular force. So if I just replace everything, this will be 981 newtons times 15 meters plus 2 times the integral from 0 to 15, right? That was the FDS, remember? FDS. This will be the 600 plus 2s squared ds. And this is equals to 1/2 100 kilograms times V2 square. All right, so let's see what we get. So we'll get out of here. Let's focus on this integral for now. Let me write on this side and then we can solve the values. So we have the integral from right there will be 600s plus 2s cubed divided by 3, evaluated from 0 to 15. And from here, if we once again, don't forget that all of this should be multiplied times 2. Oh, this should be negative, right? So negative 1,400 or 14,715, and this is plus 11,250, and this equals to 50 v2 square. So solving for v2 square, we're gonna get out of here v2 is equals to about 12.47 or 12.5 meters per second after you substitute in the values.